Welcome to this brief video introducing the integration between Tekla Structural Designer and Adapt Floor Pro. This integration allows you to streamline your post-tension concrete design by starting in Tekla Structural Designer for your building design and exporting to Adapt Floor Pro for the PT slab design. In Tekla Structural Designer, I have a typical multi-use residential concrete building. The building modeling, loading, and cast-in-place concrete design will be performed here in TSD. Notice the irregular column spacings and the columns supported off the PT slab, as well as the transfer girders. Basic floor dead and live load have already been applied. Now we can switch to the transfer slab level and apply further loading. Line loads can be drawn directly on the slab to account for any walls or partitions. Point loads can be added as needed. And we can create area loads of any shape to account for any different types of loading patterns, conditions, situations that the project might have. Now for this example, I've already gone through the wind and seismic wizards, and we can see what the wind load is going to be applied and designed for. And if we take a look, we can see that all of the members are currently set to automatic design. So the program is going to optimize the reinforcing for the loads that we've applied. So now I'm ready to run through the actual concrete design. We can see a detailed breakdown of the process as the program works through the analysis and design, and it's optimizing the reinforcing for all the gravity and wind combinations, then performing a design check for the seismic combinations. And all of this is done quickly and within a single model. We can see a color-coded pass-fail screen once it's done, and member designs can be reviewed. TSD will show you detailed information on how exactly the member is being designed, with equations, code clauses, and detailed information to really eliminate that black box feel. For concrete design, we also have the ability to use the interactive design tip, and this will show you the reinforcing bars exactly as they're laid out in the beam, and this is completely dynamic and customizable, so you can come in here and make changes to the reinforcing bars. The information below is going to update with pass-fail statuses, and as you make these changes, you can also go back into the check and see how that's affecting the full design. This information can also be exported to an AutoCAD drawing where it will give you a full detailed CAD drawing with the reinforcing, section cuts, layouts, everything that you would need to then add that into your documentation package. And finally, we can also look at a load analysis view for individual member. You can move the slider bar to see more information and see all the different forces on the side there. And we can also view this information for the building as a whole. And the different force diagrams and that you see here are also changeable and customizable. Now we're ready to send this over to Adapt. So in the Home ribbon, we can click on the Adapt Export link. We just need to give this file a name and save it away. This will create an INP file that can then be imported into Adapt Floor Pro. So now let's take a look at the integration and slab design in Adapt.
Perfect. So then I'll take that file and go ahead and import it here into Adapt Floor Pro. When I do this, it's going to import all of the concrete structural geometry as well as all of the load cases and load combinations. When we do this, I can validate any of these applied loads that have come in. So this polygon load has come in as a dead load of 10 psf magnitude. I can also check that the lateral loads applied. So here for any given seismic case, we can see what the lateral loads applied are. I can also look at the model in 3D to see the effects of the applied load. So in this case, we have the dead load from the Tekla Structural Designer Global Analysis Solution, and I can review the axial loads in the columns here just as an example. Let's go to the podium level. The first thing I'll need to do to create an analysis on this side in Floor Pro is to create a finite element mesh. Then I'll analyze this slab. This solution is uniquely set up to handle a single level analysis of floors that are part of multi-level solutions. So we have tools here where I can directly include the applied lateral loads and gravity loads. So I have all of the reactions from these various lateral cases as well as the FZ direction loads from these gravity cases. Now that that solution has completed, I can quickly validate the gravity response. There are a few ways that we can get PT into our model. I can simply build and define new tendons that go through the floor plan. I can also optimize tendons based off of support lines, and additionally we have a tendon optimizer tool which I can use to optimize tendons span by span. I'm going to switch over to a model where I already have a proposed PT layout so that we can review the workflow of looking at results. I can pick any one of these tendons. Looking at it in profile, I see this is a group of 10 tendons with its associated profile shape. You can see the CG points and where they reference off of at each point along its length. I can now review results. We can take a look at results like deformations along the length of each support line. I'll get a status check of OK or no good with each check here. We can also check top stresses, bottom stresses. Here we can clearly see where we have an area that is overstressed, and again there is a no good status here. We can also check pre-compression and balance loading. Let's take a look at the rebar requirements. So this gives us the serviceability and strength rebar required, and further we would check punching, shear, and other parameters to complete the design. This concludes a quick view of the new link between Tekla Structural Designer and Adapt Floor Pro. Please contact Adapt or Trimble to learn more.